All right, so I'm going to go over some limits that take x to infinity. You can do the same thing with negative infinity. All of these go to positive infinity. Essentially, what you're trying to assess here is end behavior for the function or um, the quotient of functions. So let's take a look at the first one, which should be the easiest of the three. It looks like. So this is a cubic. We've got negative 3x cubed minus 25x squared minus 12x and then minus 17. It's a cubic. Typical cubic is going to look something along these lines. It's either going to do something like this if the coefficient in front of your cubic is positive, and if it's negative, it's going to go the other way. So if it's negative, it's going to look more like this. And this will just go on forever. So what we do is any sort of this sort of polynomial, if it's an odd polynomial, it's going to look like that. An even polynomial will look more like a parabola. Will either open up or down. So, from algebra, what happens with these? Well, we have a cubic as x goes to infinity. Since our value here is negative, we're going to go to negative infinity. So that's what's happening here, right? If that was to the fourth power instead, that'd be opening downward, also negative infinity. Now, when you have a polynomial over a polynomial, you assess the largest order coefficients with each of these. If you have a situation where your denominator has a higher exponent than your numerator, well, then it's simply a 1 over x situation. That's not what I want. Let's do 1 over x real quick. So if f of x, or I guess limit as x goes to infinity of 1 over x. Well, the function 1 over x looks like this, right? Makes sense? Well, at least as x is going that way. So this is getting really close to 0, but it never actually hits 0. But this equals 0. Again, going to positive infinity. Function looks like that on the other side, but we're only interested in going to positive infinity for this. So if our denominator has a higher exponent, so instead of x to the 9th down there, if it was x to the 10th, we'd be in a situation where we're increasing faster than we're decreasing, and it's going to go towards 0. All right. If you've got a situation where your numerator is larger than your denominator, then it's going to put you in more of a situation like this one here. You ascertain the numerator and go from there. Now, be careful. You're going to want to look at the highest order coefficients here. So if we had an x to the 10th power on top, it's going to go to infinity. However, because this is going to turn into essentially 7/3, these two are going to dominate everything else that happens. All of those other lower ones don't matter. So it's just going to be the 7 and the -3 that matter. So again, if that was actually the 10th on top, we would be going to negative infinity because you got a 7/3 times infinity, which would get you negative infinity. Here, when you have the same order of exponent, they're both to the 9th, these are all going to go away, and we're just going to look at the coefficients, and this answer is -7/3, or 7 over -3 if you prefer, whatever. That's what this limit equals. Essentially, what we do there is we divide, or I guess we can multiply both the numerator and denominator by 1 over whatever that is. So let's try that to see if we can do that. So if we multiply by 1 over x to the 9th, or x to the -9th if you prefer. that means we have the limit as x approaches positive infinity of 7, well, x to the 9th over x to the 9th is just 1, so it's 7, minus 4 times 1 over x to the 4th, plus 2 times, no, 2 times 1 over x to the 8th, minus 13 times 1 over x to the 9th. Well, and again, all over, what do we have? Negative 3 times 1 minus 1 over x minus 5 over x to the 7th plus 2 over x to the 8th. Each one of these goes to 0 as x gets really big in the 1 over x scenario. 1 over x to the anything larger than 1. All of those go to 0. So these go to 0 and these go to 0. So we're left with simply 7/3. And again, that's our answer, 7/3. This next one, it's not a polynomial, but it's something that we should be able to ascertain pretty easily. This is the same as writing a limit as x approaches infinity of 3 to the x minus 1 over 3 to the x. And then 3 to the x plus 1 over 3 to the x. So it's in a situation where it looks like what we did over here. So as x goes to infinity, this bit goes to 0. You put a really big number in for x, say a million, it's 1 over 3 to the 1 million, which is a huge number, which brings us all the way to 0, or approaching 0. In a similar fashion, this goes to 0. So this approaches 3 to the x over 3 to the x, which is going to be the same as we go through, so this just equals 1. And that's how you deal with some of these problems.